Right now, in labs all over the world, physicists are firing single particles, and those particles somehow seem to know if they are being watched. In this explainer, we are diving into what is arguably the most repeated, most verified experiment in the entire history of physics. And it proves, without a doubt, that the universe is just not what it appears to be. So picture this. You fire a tiny particle. Somehow, it knows you're watching. It acts like a rippling wave when you look away, but the absolute instant you observe it, boom, it becomes a solid bullet. I know, it sounds like pure science fiction, but it's not magic. This is reality at the absolute smallest scales. Which really begs the question, does reality even exist before you look at it? Okay, to understand just how crazy this actually is, we have to take a quick trip back to 1801. A physicist named Thomas Young set up a really simple but brilliant experiment. He used a light source and a barrier with two narrow slits. His whole goal here was to settle a massive debate that was raging at the time. Is light made of tiny solid particles, or is it a wave? The contrast between our everyday common sense and how nature actually works is just wild. Think about it. If light were made of solid particles, like tiny marbles, you'd expect them to just pass straight through the slits and form two clean, bright stripes on the back wall. But reality delivered something completely different. It created a wide spread of alternating light and dark bands. Now, that alternating pattern is the ultimate fingerprint of a wave. It's called an interference pattern. Just imagine dropping two pebbles into a pond. When the ripples overlap, the crests push together to make a larger wave, which in this case means a brighter light, and the troughs cancel each other out to make a dark spot. Seeing this, 19th century scientists confidently close the case. Light is a wave. So, case closed, right? Well, not exactly. Let's fast forward to the 20th century. Scientists evolved the experiment. Instead of a beam of light, they started firing single, solid particles of matter. Specifically, electrons. They fired them through the exact same two slits. And remember, we are not dealing with light anymore. These are actual, physical pieces of matter. Common sense absolutely screams that a single electron, fired all by itself, should act like a tiny bullet. It should hit the screen in one spot and eventually build up into two boring stripes right behind the slits. But instead, scientists got the exact same wave pattern as light. Just let that sink in for a second. Somehow, a single, solid electron is fired completely alone. It is in a vacuum, there are zero other particles for it to bounce off of. Yet it spreads out, travels through both slits simultaneously like a wave, and essentially interferes with itself before hitting the screen. One single piece of matter is literally in two places at once. Naturally, physicists were completely baffled by this. I mean, how is that even possible? Which slit does a solitary electron actually go through? So, to find out, they placed a harmless little detector right at the slits. They didn't physically block the path, they didn't touch the electron, they just turned on what is essentially a camera to passively record which way the electron went. And this is exactly where reality completely breaks. The exact moment they turned the detector on to measure the path, the interference pattern vanished. Just like that. The electrons instantly reverted to acting like ordinary little bullets, making two clean stripes on the wall. The mere act of observing the particle completely changed its physical outcome. But wait, it gets weirder. If you turn the detector off, the wave pattern instantly comes back. Turn it on to watch again, it disappears. Every single time. It was almost as if the electron knew it was being monitored and decided to hide its strange wave-like behavior from us. I want to be incredibly clear about this detail because it is absolutely crucial. This is not a measurement error, the equipment isn't clumsily bumping the particle. Any interaction that extracts which path information fundamentally alters reality. It doesn't require a conscious human mind looking at it, it's just the universe reacting to information being pulled out of it. To make sense of this impossible behavior, physicists use something called a wave function. What this means is that before a measurement takes place, the particle literally isn't in one single defined location. Instead, it exists in this mathematical cloud of infinite possibilities. It is everywhere it could possibly be, all at the exact same time. But when you finally measure it or force some kind of interaction, this cloudy wave of possibilities immediately collapses. It resolves into one definite, concrete outcome. The universe goes from maybe everywhere to definitively right here, in a tiny fraction of a second. the possibility suddenly becomes reality. And this bizarre logic is exactly why Erwin Schrödinger imagined his famous cat in a box with a radioactive trigger. That thought experiment really highlights the sheer absurdity of it all. Until you open the box and actually observe it, the quantum equations literally treat the cat as both alive and dead simultaneously. The cat is basically a macroscopic stand-in for that blurry quantum cloud of probability.
It is absolutely vital to understand this next point. It's not that the cat is definitively alive or dead, and we simply just don't know yet because the box is closed. In a very real, mathematical sense, neither outcome exists until the observation forces reality to make a choice. Reality itself is suspended in a state of both until an interaction happens.
Now, nearly a century later, physicists are still fiercely debating the why behind all this. Some point to the Copenhagen interpretation, where the wave function simply collapses. Others really prefer the many worlds interpretation, suggesting every single possible outcome creates a new branching universe. And some think hidden pilot waves guide the particles. But despite arguing over why it happens, there is overwhelming, undeniable agreement that it absolutely does happen. And before you dismiss all of this as just strange academic philosophy or weird math tricks that only matter in some isolated lab, you really need to know this. This bizarre quantum behavior is the literal foundation of our modern technological reality. Think about it. Every single time you scroll on your smartphone, you're using semiconductors that are governed by quantum tunneling. When you get an MRI, that relies entirely on quantum spin. Use GPS to find a coffee shop? Quantum-corrected clocks make that possible. Even the hydrogen fusion that powers the sun relies on quantum tunneling to shine. Without understanding that matter behaves as a wave of probabilities, none of this technology would even exist. So, far from being a wild guess, quantum mechanics is actually the most precisely tested theory in the entire history of science. It is accurate to roughly 1 part in a billion. That is just an astonishing level of precision for a scientific theory that basically states nothing is truly fixed until it interacts with something else. We didn't build this weird, confusing theory because it's comforting or easy to wrap our heads around. We built it because time and time again, it is undeniably what nature actually does. The universe is far stranger and far more deeply interconnected than our everyday senses allow us to perceive. Which really leaves us with this final, completely provocative thought. If reality doesn't completely lock into place until it's observed, how much of our vast, unmeasured universe is still just a landscape of probabilities, waiting for us to look? If this explainer made your brain itch a little bit, well, that is a perfect reaction. Let us know in the comments if you want us to explore how this exact weirdness is being used right now to build quantum computers. Thanks for learning with us.